Welcome back to our continuing series on Chapter 6, Commercial Arithmetic. We are continuing with compound interest formula. We should realize that calculating compound interest using the method of calculating simple interest yearly and adding up every interest on the principal to get new principal for the new year is long and tedious. We need a formula which can give us the final amount directly or quickly. Let us use steps we followed in activity 1 earlier on, but only up to end of year 3, so that we can derive a formula or the formula we need for calculating compound interest. We should see that total amount is got by adding the earnings accumulated at end of every year to the previous existing amount called the previous principal to get new principal, and then let us use simplify the rate. Instead of writing it as a fraction of 100 or percent, we make it r%. This way it be short and easy to work with, and then time, because we are going to work with compute interest yearly, we'll make time t be equal to 1. Then we move forward to look at the total amount and after 3 years, which should be the principal invested, which Mary put in at the beginning, plus interest in the first year, plus interest accumulated in second year, and plus interest accumulated in the third year. That should be the total amount at the end of third year. And we will call that, or we need to go back into our knowledge bank to really see that the total amount at the end of first year is the principal investment plus the interest it earns in that one first year, which is rate percent times the principal, as it were, and which this amount is now the new principal as we get into second year. So when we get into second year, we have the total amount as the amount accumulated in first year, which is the initial principal plus the interest it earned at the end of first year, such that at end of second year, new earning interest is earned from the rate and the existing principal, which was accumulated in the first year, and this amount now becomes the new principal for third year. At the beginning of third year, this is the total amount in that account, which becomes a new principal. So at the end of the third year, we have the total amount accumulated as the amount we got at the end of first year, plus interest which was accumulated on that amount in the second year. This is interest accumulated in the second year, plus the interest accumulated in the third year. And in the third year, the principal is the amount which was accumulated in first year, plus interest, which that amount, the amount accumulated in first year, and at end of second year. This is interest, the new principal after first year, and at the end of the second year. So this is the amount of principal in the third year, and therefore interest in the third year is rate times that whole principal. We open these brackets to get that expression simplified as the initial principal, the first year principal, plus second year interest, plus third year interest, getting as P plus R percent P plus R percent P. R percent P comes from R percent times P, that gives us R percent P, plus R percent times R percent times P, that is R percent squared P, plus R percent times P, R percent P, plus R percent times R percent P is R percent squared P, we have it here, plus R percent, rather, is this R percent here, R percent times P is R percent P. Where is the R percent? R percent P. This R percent times R percent here times P gives us R percent squared P, plus, now we have R percent times R percent times R percent P is R percent cubed P, or times P, which is R percent cubed P. We have it here. Now, because P is common in all of them, P is here, 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 P is there, we pull it out and put it outside a bracket. So P into opening bracket 1, because it is P times 1. P times 1 gives us that P, plus, let us look at the R percent. R percent are R percent P. R percent P are 1, 2, 3. 3 R percent P's are there. Then let us look at R percent squared P. R percent squared P are R percent squared P here is 1. R percent squared P is here. That's a second one. And the third one, R percent squared P. So 3 R percent squared. And then we have the R percent cubed P. So R percent cubed is here. Close the bracket. Very good. So now we have this expression here. And this is a standard expression, which we will know later on how it comes about, using what is called binomial process or expansion. But in the meantime, we just collect these terms and so on, and we would see that 1 plus R percent into bracket cubed, when we expand that, we definitely get 1 plus R percent into 1 plus R percent into 1 plus R percent, which gives 1 times whatever. 1 times 1 times 1 would give us 1. Then all the rest of the things, when we multiply together, we'll get R. The whole thing as R cubed. We'll get this. We'll get 1 plus 2R squared. 2R percent plus R percent squared, and then plus into 1 plus R percent, so that eventually we end up with the same expression as we had got up here. Here we are, with the P outside. That is the expression which you get when we add all this piece which we got from up here, the total amount at the end of third year. This then gives us an expression which is a formula for the total amount accumulated at the end of year 3 as P into, open bracket there, 1 plus R%, close the bracket, squared, at the end of year 3. Which brings us to think and suggest that perhaps the total amount accumulated through this compound interest at the end of a duration called T, maybe T years, would be P into bracket 1 plus R%, close the bracket, raised to power T. Remember that here it is raised to power 3 because we are talking about 3 years. But we shall see, or try to confirm that in the next bit. Let us look at task 2. In this task, you are going to work on the following. Solve the following problems. Take pictures and the work area and send to the WhatsApp line. About 20 minutes or so about there to work and finish this. Use the formula P into 1 plus R raised to power T to work out a total amount at end of year 3 and compare your answer with, to the answer we got when we did the compilation or calculation using a simple interest method and then adding the interest before computing the next year's interest and so on. Compare those results and see if they are close or something else. In number 2, you simplify expression for total amount at end of year 1 and year 2. That is the accumulated amount at the end of first year or year 1. You add to interest it acquires in the second year, so that the total amount at the end of year 2 is this amount here. Expand this, collect all the like terms together and see what kind of equation you come up with, and you're going to compare that equation. And then the third last bit is from the result you get here and there, respond to the question that is it sensible and reasonable and fair and true to conclude that the general formula of the total amount an interest earns after T years is given by P into opening bracket 1 plus R%, close the bracket, raised to power T in compounding compound interest formula. And explain you how you come to the conclusion depending on your results here. Probably that may suggest that indeed it holds here, it holds there, it is true here, it is true here, therefore it is true for all. Just confirm that. Thank you very much. See you next